Hello everybody. Good afternoon. Thank you for being here today. So we're gonna talk about who's watching the watchers, and as we all know, the AI systems are supposed to be our current watchers, where they're watching everything, doing everything for us. So I'm going to talk today a little bit about who's watching these watchers. What that means is I'm going to talk about AI evaluation. Okay, so there's been like a big revolution in the AI space recently, but one of the more overlooked parts of that revolution actually has been the AI evaluation, or the LLM evaluation part. So Greg Brockman from OpenAI famously noted that evaluation is surprisingly often all you need to make a successful product from an LLM or an AI implementation. So in the production systems, your model is only as good as your ability to measure it, right? So there are all these models out there. Everybody has some kind of an AI implementation. But when people ask you what is the advantage of having this, you have to have a way to measure it and better it. And you have to do this over and over again for it to become a part of your system and for it to be successful, and most importantly, for your user to adopt it. Because unless your user adopts that AI system, it's basically like, yeah, you can go build the best system, but there's nobody who's using it. So your worth is determined by your user experience and how much user adoption you can actually bring. I'm going to talk a little bit about myself, just give a quick introduction. So my name is Supriya Bachal. I work as an AI ops engineer, project manager with Siemens Digital Systems. So I'm passionate about solving real-world problems using AI. I work across cloud and data pipelines. I love building systems that are scalable and impactful. So I went to Michigan Tech, so I don't know if any of you guys are here, but go Huskies. I run on coffee, so if you met me without I've had my first cup of coffee, I'd be a very different and bad person who you didn't want to meet. When I'm not working, I'm traveling to new interesting places, I'm swimming, I'm trying new food haunts around places, and I'm hiking. So if anybody has any good food recommendations, if you see me in the alley, please do let me know. All right, so moving to the more LLM evaluation part. So in the early 2000s, right, like LLM is creating all the buzz right now, search engines were the ones creating the buzz back then, right? And there were so many of them. There was Google, there was Microsoft, there was Yahoo, and everybody claimed to be the best search engine out there. And everybody had a lot of engineers who were very talented, and everybody was trying to say, ours is the best. So, and today we are here in 2026, and I think Google really dominates this space today, right? So most of the search that happens on the internet today goes through Google. Now, what made this happen, right? Only one of the systems appeared to be the world leader, and it happened because of the better quality of search. One of the key reasons for that is better evaluation. If your evaluation reflects what your customers want, then you will make the best system. Google won because their internal evaluations actually aligned with the user's perspective. So the takeaway here is that evaluation is just not a technical step to put your stakeholders at rest. It is the actual cornerstone of your market success. So how successful your product is going to be. So the purpose of this presentation is to give you guys a view of what I have learned in my short time with working with LLMs and working with evaluation in general. I want to talk about it from the point of view of what principles to use for evaluation of your systems. So a couple of things which I want to point out before we dive deep into the technicalities, right? There are a couple of principles with LLM evaluations. So one of the principles is that the evaluation of your system depends upon your customer, as I already said. There is no metric that is final or perfect. It is more important to understand the principles of building evaluation data sets for your specific business needs than to blindly follow a benchmark invented by somebody else. So in short, what I'm trying to say is there is no one size fits all kind of a solution to evaluation. You need to develop your own solution by leveraging what's out there and what the standards are. So in the LLM and AI space in general, there are kind of three parts to it, right? So the first part is the pre-training part. So pre-training is a very niche use case, right? One, because it takes a tremendous amount of money to do, like to develop your own model, pre-train it, get it out there, make it very, very niche to your system, right? So most companies don't play in this space. Most companies play in the second space, which is the fine-tuning and instruction tuning space, and the LLM-based system space. So there are evaluation metrics that you could use for pre-training. There's Squad 2, there's SNLI, there's Glue, and other evaluation methods used at the early stage of LLM development, which is pre-training. Building LLM products in many companies is about instruction tuning for models, training adapters, building LLM augmented systems, and continuous circle of improvements of those systems. So very few companies will work on the first stage. Most companies will do fine-tuning, instruct tuning, and training adapters to create a model for your customers. Then you create a whole system around the LLM, and it could be an information retrieval system like a RAG, or an action using, say, API calls, or an LLM agent doing some task for you, whatever it might be. That's the last part of your system. So we're going to focus on the second part where most of us are going to be playing. We're not going to focus on the pre-training part because that's highly academic and there are a lot of papers out there about it, but we're going to focus on the more practical side of this. So where AI systems have evolved from is we all have had the data science, machine learning era before we got into the AI systems era, right? And so classic machine learning is evaluated differently than LLMs. And then the question is how so? So machine learning and data science work is in many ways not like AI work. And the reason for that is because when you do data science and ML, you have one model that predicts one result, and you have to evaluate only that one result. So your model is very specific to doing just one task. And that task you create metrics for, and those metrics you evaluate. It's not, I won't say it's easy, that's still difficult, but it's easier than evaluating like an AI model, which is doing so many different things at the same time. So say you want to predict your own e-commerce, right? You have a shop, you want to predict your e-commerce sales. What is the best price for your product? You put your website, you have certain metrics like the highest probability of conversion, the highest revenue, the company that is going to create that revenue, and some more complicated metrics to tune your model. But there is still a very clear metric. When you move to the AI space or the foundational models, they handle dozens of tasks simultaneously. So we aren't just measuring right or wrong or a single point number anymore. We are measuring knowledge, reasoning, linguistic nuances, semantics, and all this across massive areas, right? Massive semantic areas. So traditionally, models were evaluated and trained against one specific metric, like I said before. Um, but foundational models, you have one model and many different tasks within your company. This creates a lot of complexity. So when you tune a model for one task, it is easy to create the state-of-the-art results that we have been doing. But how are you going to progress across all of them as you improve your model? And you'll always have new tasks that are added to the model that you created. So this slide shows a couple of tasks that LLMs usually are doing within different companies. And perhaps your company is not doing all of them, but I'm sure that there is some points or multiple points in this diagram that you are touching. These are the semantic areas. So these are how well AI does on different semantic areas with the same business. As you can see, the performance varies greatly. So if you were to choose an area that is very well aligned with AI, you're going to get better results. But if there's something else that's not so well aligned, your benchmark itself changes, because we know that AI doesn't do very well in that field. So within a company, you will not have a huge coverage of NLP cases, but some things like summarization, classification questions, and answering natural entity extraction is kind of common. Most companies are doing it now. So different query understanding the tasks, items understanding the task, it will be used for the same model, right? So many different teams will use this, and frequently the teams will be from very different departments. So as you're working on the progress of fine-tuning and fine-tuning, instruct tuning, and other parameters on your model, it's important to build an evaluation set that will be very big with a variety of different tasks. And you will not overtune a model for a particular task, because many customers inside a company and many customers externally will be using this. So when we build evaluation sets, we have to make sure that we don't introduce bias within those sets itself. So don't overtune for one certain task, right? Yeah, so again, to summarize, LLMs and ML evaluations are different. ML evaluations do one thing. LLM or Gen AI use cases or AI in general does multiple capabilities. It has multiple capabilities. So it does knowledge recall, reasoning, language generation. Also, another important thing to remember with LLMs and AI in general is that they directly interact with the customer. So there is no layer. So when you develop a LLM model, we are at higher risk, right? Because you have the customer who can directly go and query all that data, and the answer that comes out of this, you have to think about things like it shouldn't be offensive. It shouldn't say something that is biased. It shouldn't hurt anybody's beliefs and stuff like that. So that is another part of evaluation that we have to take care of, which is called ethical evaluation, that is new to AI versus the ML models. So the next question is like, why even evaluate, right? And a lot of companies are actually in this limbo right now, because AI is moving so fast. People kind of want to believe that it's good and put it out there as soon as possible, and get with the race, get going, deploy models quickly. So one of the main questions, which is more of a strategic question that comes up often, is, do we really need evaluation? Why do you want to evaluate your model? So when launching a new model, we have to think about what is the business outcome of that model and what user experience are we providing with it. So better customer satisfaction, higher conversion rates, how reliable are the outputs? These are questions we should answer before we put it out there. So we have to ensure a safe product launch. We need to make sure that it is ready for the users. We need to make sure that it doesn't generate any toxic or biased or harmful outputs. That said, when it's a multimodal model, which means that it has videos and images in it, it's even more harder to do this evaluation for biasness. So it's a huge task. We have to evaluate the end-to-end system, not just the model. So the model, the prompt, the pipeline, and we have to focus on real-world behavior. So evaluation is not just validation, it guides development. So whatever output you get out of your evaluation is basically going to be the input for your next development cycle for your AI. And that's how it should be. That's how we're going to get to the point where you're going to make a good user context friendly model. So for the evaluation sets, right, what does good look like? So there has to be a success criteria. It has to be very clean success criteria. There have to be optimization targets, and there have to be evaluation metrics. So those are the three things that are kind of really important for your evaluation data sets. Continuous improvement, as I said, tune, adjust, improve pipelines continuously. It has to be incremental. And then ultimately, you have to determine whether your whole system is successful, not just one part of it. So I might have the best embedding, but my whole model may not be great because my reasoning is not good, or my indexing is not good, or something else is going wrong. So we have to, it's almost like doing integration testing from a very like software perspective. All your evaluation that you do for different parts of your system need to kind of get together, and you need to evaluate that as well. So evaluation doesn't just measure LLM performance, it defines how the entire system is going to evolve. I already said we just gonna get a little deeper into the continuous process part. So for it to be a continuous process, there are some prerequisites. And the prerequisites are that your evaluation process must be fast, cheap, and automated. It has to have evaluation metrics which are correlated to the customer and business metrics. So basically, whatever you're evaluating, does your customer actually care about it? That's the question you need to ask. And the evaluation must cover different aspects of the use of the LLM. So semantically, what kind of use cases is this going to solve? And then there are always going to be new use cases that's going to come for your LLM, right? And you need to adjust your evaluation cycle and your evaluation metrics according to whatever comes your way. This is kind of similar. It's alignment, representation, systems, and statistics. These are the things that we spoke about in the previous slide, just in a different way. These are the requirements for evaluation, for a good evaluation. So let's get a little more into the technical part of this now. So there are two types of, there are many types, but primarily two types of LLM task categories, right? One of them is the generative tasks. And what is the generative task? So the generative tasks are the LLMs that create content. And then there is the other type of tasks, which are the embedding tasks. So embedding tasks are LLMs understand and represent content. So they're not creating anything new, they're just ingesting what you have already, and they're going to give you answers based on that. So for like embedding tasks, think about all the user manuals that your company has, right? All of those user manuals can basically be embedded and put into this huge system, and then anybody can go and query that system and break silos within the company. So all your departments now have access to all the knowledge from everything else. Another point about this is, for evaluating data, an interesting thing that's kind of developing right now is people don't want to share some kind of data with everybody. So another evaluation metrics kind of to keep in mind is, and this goes a little bit into the data governance part, but we still need to evaluate this on the AI ops side. You need to have access boundaries for each type, like group access for each type of user, which brings us to user persona. So your one user cannot have access to everything. You have to determine who has access to what. We need to evaluate according to the user persona. So there will be different evaluation metrics to that different user persona. So yeah, so all I'm trying to say is there's embedding tasks, there's generative tasks, there's two types of tasks. We need to evaluate them differently. So first let's talk about the embedding evaluation, because I think this is pretty common across right now, everybody. So they're one of the most important applications of LLMs because they power like RAG, they power recommendations, they work by converting text into numerical representations called vector representations, and they enable systems to understand like semantic similarity instead of just keywords, right? We have a challenge here, and the challenge is that different tasks like retrieval, ranking, clustering across different types of data and different use cases use the same embedding models, and we have to often expect a single embedding model to perform well across all of these different problems. So the key is generating embeddings, but making sure that they're aligned to the specific task and business context. So MTEB, which is Massive Text Embedding Benchmark, is a good evaluation framework that we can use. So this evaluates how well embedding performs by itself, and it measures it across various tasks like retrieval, clustering, similarity by testing them on standardized datasets. So it's a widely used framework for evaluating embedding models, and it covers 8 core areas, which include retrieval, re-ranking, clustering, classification, semantic similarity. There are a couple of more in there, but these are the main areas. And there are comprehensive benchmarks available within this MTEB framework to evaluate these tasks. So MTEB evaluation, so a lot of people put MTEB to the test, and we have a leaderboard that they created, right, using this framework. And one of the most important insights that stands out is there is no single model that performs best across all these tasks. So different modules perform better depending on what you're optimizing for, whether that's retrieval accuracy, clustering quality, or similarity scoring. This has a direct implication on how we design systems in a company setting. So again, not a single embedding model is going to solve all your problems. So another advantage of MTEB is that it's open source and it's highly extendable. So if you want to get started with something quick and dirty, really your very first step where you want to do evaluation for your models, MTEB would be probably your first step. It's a plug and play framework. So you can plug it into your own models and use it. You can evaluate them on your own data sets. So it's critical because you could use academic evaluation frameworks like Rouge and Blue, and we've heard all of them, right? But the problem is that these frameworks may work in a very academic controlled environment, but once you put it into production, it may or may not work. So MTEB basically helps with that transition from you have developed a LLM and good AI model you think which is great, and now you want to put it out there for your customer to try out. You probably want to do MTEB before you do that. So there are standard traditional metrics like precision, recall, NDCG. So these are very common, especially for information retrieval systems. But it's also important to understand that these metrics were originally created way before AI was even in the picture. And they are not optimized for AI. They were originally designed for very different systems like web search in the early 90s, and they have use cases like that. So today LLM systems are much more complex, user behavior has changed. So if we inherit these metrics without questioning them, we might end up optimizing for something completely different than what we actually want to optimize for within our company. The query distribution, for example, and your users are unique. So your evaluation metrics should reflect your specific business goals and how customer expects your queries to be, or how you expect your customer queries to be. Not all outcomes are equally important for you. So you're going to have to make that trade-off at some point and prioritize what in the evaluation matters most to your customer in the use case. So there is always going to be that trade-off where your LLM model is not going to perform well on everything. There are some tools out there that are, again, ready to use for evaluation, which have all these metrics kind of inbuilt in them. So ML Flow is one of them. You can definitely use ML Flow, just plug it into your model, and it should start giving you monitoring as well as evaluation. So software performance is another important thing. So you might have a very accurate model, but you also have to meet the latency and throughput and cost. Every query that goes to an LLM should be answered within a certain period of time. Only then is the user actually going to turn to that LLM to be able to answer it, right? A lot of people who I've worked with who were averse to LLM kind of is, when we got into this whole thing, thought that I can do it, and I can probably do it in the same amount of time that the LLM can. But then they realized that the LLM can actually do it faster than them. And that's when the change happened, right? So you talk about Claude Code, and you talk about all of these systems that are generating code for software devs, right? And that's really catching up right now with vibe coding and all of that stuff happening. Why do you think that there is a major adoption for this? I mean, our software developers can still write code. They write it all day long. The companies are pushing for this because their LLMs are doing what software devs do much faster. And I don't know if they're doing it better, but they're definitely doing it faster. So one of the things that's a major evaluation criteria for LLMs of any kind is the latency. So it has to be faster. Otherwise, people are just going to say, I'm going to do it. So most people think of LLM as like a text similarity output, but that's not the only evaluation point for this. So you might be generating data which is very similar or which answers the query, but it's a whole process. It's rank, recommendation, and then output. So all of those parts that go into embedding the data are actually need to be evaluated and are very important for your final system to work well. So ICL, which is in-context learning, is when a large language model learns how to perform a task just from examples given in a prompt without any additional training. So in-context learning is one of the most powerful but also challenging capabilities of LLM to evaluate. So the difficulty to evaluate this comes from the fact that the model has to do multiple things at once. It needs to understand the task, learn from a few examples provided in the prompt, figure out the underlying pattern, and then apply that to new inputs using the contextual cues. Because of this, ICL is not straightforward. And you can think like, this is like machine learning, but in machine learning, you have something which is called a loss function. in every model that you build in machine learning, there's something called a loss function. And that loss function is quite clearly defined. But with ICL, we don't have a clearly defined loss function. And that is what makes it much harder than a normal ML workflow. It has strong practical value, and it enables use cases like code generation, what I was just talking about, building classifiers without explicit training. So there are a couple of benchmark data sets that are used for such specific use cases for ICL. One is the Pika data set. Show of hands, has anybody heard of Pika? No, not at all. Okay. So Pika is a data set that's used for ICL. There's Hella Swag, there's Lambda, and all these data sets basically test different aspects of reasoning and language understanding. So it needs a wide range of linguistic and reasoning challenges, and it's a comprehensive way to kind of assess LLM capabilities. So there are frameworks which provide structured ways to run this open evaluations, right? It's called OpenICL. That's a tool that's used, and it basically is a more structured way of going through these evaluations versus using data sets and then integrating them into your model and all of that stuff. So you can definitely go try that out. So this is an example of how we evaluate in context learning using benchmark data sets. So the first example is Pika, which focuses on common sense reasoning. The model is given multiple answer choices, and it needs to select the correct one based on physical and everyday reasoning. So this helps us understand how well the model can apply real world knowledge, which you see here, right? It's given two solutions, it has to choose the solution. The second example is the Lambda dataset, which tests deeper language understanding. And here the model is given multi-sentence context and must predict the final word. This requires understanding the full context, not just individual sentences. And together these benchmarks help evaluate both reasoning and contextual comprehension. So we have two data sets, one is Pika, one is Lambda. There are different use cases for them. One is multiple choice, one is just understanding the full context of the text that you're given. The third type of evaluation is LLM-as-a-judge. So when you are evaluating an LLM, you could get a human in loop, and you could create like a golden data set for what answers you're expecting. Like a human gives you those answers, and then you just check against those answers how well the LLM is actually performing. And this is the same concept that is used in LLM-as-a-judge, except that instead of a human, you're getting another LLM to do that part for you. So this is mostly used for RAG. It's used for natural language questions. LLMs themselves evaluate other LLMs. Most of the times, a larger model is used to evaluate a much smaller model, right? A larger model. So then the question is, why don't we just use a larger model to do all our tasks, right? What's the point of like doing this? The point is basically using a larger model costs more, and maybe the task that you're evaluating for doesn't have a good enough ROI to use that bigger model. So you do have a bigger model in your suite. You're going to use it minimally just to evaluate the smaller model. So this is LLM-as-a-judge. The cons are it is expensive, and again, it's almost like a complete loop system, right? You are using another LLM to judge one LLM. So would you completely trust it? No, but can you use it as one of the evaluations in your suite? Sure. So these are the most frequent like patterns for LLM usage that we kind of evaluate on. So RAG is becoming one of the most common industrial patterns for using LLM. And while evaluating RAG systems, we need to look for multiple dimensions, not just correctness. Yes, your answer is correct, but also comprehensiveness and readability. So your answer needs to be also understood by the user of your system. The depth and overall quality of information, and we also care about the factual accuracies. This is where you've heard a lot about hallucinations. So that's what we also care about. Whether the response is up to date or novel. And at a high level, this is similar to traditional search engine evaluation, where we assess how well a system retrieves data. However, there's one key difference. In traditional information retrieval systems, we evaluate retrieved documents, but in RAG systems, we evaluate the final generated response, which is introducing an additional complexity. And architecturally, traditional IR is retrieval followed by ranking, whereas in RAG, retrieval is followed by generation. And because of this shift, we not only need to account for retrieval quality, but also for how well the model synthesizes and presents the final answer. So RAG evaluation is more holistic. It combines retrieval and performance with generation quality. And the parameters you see here are basically going to be explained a little more in the next slides. So context relevance, answer relevance, and groundedness or precision is what we're trying to evaluate for RAG. So RAGAS is one of the, again, frameworks that's used for RAG evaluation, and it uses 4 metrics, right? It's faithfulness, answer relevance, context precision, and context recall. So I'm going to talk a little bit about what RAGAS is. Again, show of hands, how many people have used RAGAS in their systems? Okay, all right, perfect. So RAGAS is like zero-shot evaluation for LLMs. So what zero-shot evaluation means is that we don't give the LLM a golden data set. We let it just decide whether the answer is correct or not correct. So 4 key metrics, as I already mentioned. First is faithfulness, which checks whether the generated answer is grounded in retrieved context. Second is the answer relevancy. Does the response actually answer the user's question? Does it make sense? When we have context precision, which measures how much of the retrieved information is actually useful to the user, and context recall, which checks whether all the relevant information was retrieved in the first place. So it's almost like checking for completeness. So it is important to adapt these metrics for your specific use case. I've said that multiple times. I want to again reiterate the same thing, that even though all these frameworks are available there, different frameworks are meant for different use cases, and you'd have to probably come up with your own by taking a little bit from each of these, right? So overall, zero-shot evaluation provides a scalable way to assess RAG systems without requiring labeled data. So that's one of the biggest kind of challenges that's faced by people, because they want to put in an AI system into some product that they have, but to evaluate it, they need to spend like time of their employees to come up with this labeled data. And everybody's like, I have a full day job. I'm not going to sit and label data for you. Now, there are automated labeling of data, which is possible using different tools. But if your data is very niche, like for me, for example, we deal with something called CAD models at Siemens, right? So the CAD software, which has models, that data is so niche. It's very hard to label the parts and subparts of a certain model. So getting labeled data basically needs an SME to be in the loop, and that's very hard, that's very costly, it takes human hours. So what do? Then we use RAGAS, which basically doesn't need any labeled data. I just explained what the evaluation of RAG and does, like the 4 main parameters that we use for RAGAS. These are just some formulas about how we go about this maybe too technical, gonna skip through. So this diagram illustrates how RAGAS framework evaluates RAG systems across retrieval and generation. So we start with the user question, which produces an answer based on some retrieved context. Now we evaluate this pipeline using several key metrics that we discussed. So first, answer the relevancy, whether the generated answer actually addresses the question. Next is faithfulness, evaluates whether the answer is grounded and in the provided context. So we want to make sure our model is not hallucinating. Then the context precision, with measures how much of the retrieved context is actually useful. And then the recall compares the retrieved context with the ground truth to ensure that all the relevant information was captured. So this is, again, completeness. So on the right, you can see that the overall RAG flow, like retrieval followed by generation, which all these metrics collectively evaluate. So it's a structured way of evaluating RAG pipelines. There's one more way of evaluating RAG pipelines, which is not RAGAS, and that's the ARIS framework. Now, what this does is, unlike zero-shot evaluation, which you don't need any labeled data for this approach, we need some labeled data, right? So it's called few-shot prompt evaluators. This allows to achieve a more accurate and stable result as compared to RAGAS naturally, because you have some labeled data in the loop. It's reliable is like one of the biggest advantage we can see for ARIS versus RAGAS. It even performs well with domain shifts, meaning it generalizes across different types of data and use cases. It still uses the same RAG metrics that RAGAS uses, but it just uses it a little differently. So it uses statistical techniques to ensure confidence in its results. So when there are a small number of samples, we can use this technique when we have a little small data set, and we can be confident of our evaluation results for our RAG systems. To run the ARIS evaluation system, we need three main inputs. So first is a set of passengers from the target corpus. This represents the actual data your RAG system is retrieving from. Second, a human preference validation set, typically maybe 100, 150 or more annotated examples. These are used for ground evaluation and to provide quality, like reference for quality, benchmarking for quality. And the third, a small number of few-shot examples, usually around 5 in domain query and answer pairs. These are used to guide the LLM during synthetic data generation, and together these inputs allow ARIS to scale evaluation, right? So it takes all these inputs and it creates its own data which is similar to the data that you give it. So now actually it's evaluating against a very large data set that it created using the small data set that you gave it. So this is the end-to-end workflow of the ARIS evaluation system. I already mentioned what it needs. We're going to skip through this. So we're going to dive a little deep into the ARIS framework. So it generates synthetic data by creating question-answer pairs, right? That's the first step. This includes both positive and negative examples to improve robustness. So we don't want it to be biased towards one case versus the other. Next, for key metrics like faithfulness and answer relevance and context relevance, it fine-tunes the LLM as a binary classifier. So for those of you who are kind of data scientists or have machine learning experience, you guys will identify with this term. So performance is validated. The performance is then validated using a human annotated preference data set. It also samples in-domain query answers and context triples. Then it uses LLMs to classify them, enabling scaling evaluation across the pipeline. So RAG system is more reliable than assigning an absolute score, right? Because synthetic data can also introduce noise. We've seen this, like when you create synthetic data from a data set that's there, it does introduce noise. So that's one thing to keep in mind when you're using errors as well. What that means is don't use it by itself, do multiple evaluations, because even though it is more reliable than the RAG system, it might not be foolproof. It usually does better with domain adaptive prompting than RAG does. So if you're changing domains with the LLM quite continuously, if you're going to have different semantic use cases for it, go with ARIS versus RAG. It's overall more robust and scalable. So LLM in production. So now this is again another very different kind of a point of view of looking at LLMs. So when you're using them in production, right, your online serving, streaming, or batch processing, we often kind of want to concentrate on the NLP evaluation metrics, but it is also equally important to evaluate how these systems perform from a software operational perspective. So for example, you have to think about how are you going to scale this when you're building it. We're used to doing this for software solutions, not so much for AI solutions. So for example, an embedding model might need to support over 1 million queries per second with strict latency requirements, also in an online setting. So how are we going to solve these problems, right? So there may be batch systems, may process thousands of phone calls, transcripts. You see this within your teams sometimes, right? When there are multiple people talking on a Teams call, and if you've switched on transcription, there will be a certain blank space in between because it can't make out who's saying what. So just stuff like this. In production, there are going to be challenges with scaling it, with robustness, all of that stuff. So beyond accuracy, LLM systems must meet performance requirements, scalability, latency, throughput. They must be reliable. So GPU utilization metrics. So this is another way of talking about LLM productivity or performance. So nowadays, people are not talking about only how accurate it is, they're also talking about how many tokens does it burn, because that's what's going to eventually decide your ROI on your system. So you have to think about GPU utilization metrics. So when deploying an LLM in production, you have to think about, and not just think about, but also monitor GPU utilization and performance metric. We looked at throughput, we looked at latency, which is all great, but also token burn. So to break latency down a little further, the time to first token is important for perceived responses. So while total response time and the time per token help us understand the generation efficiency, but the time taken for the first token to deliver is the most essential parameter to monitor on your models. Some of these can be optimized without changing the model itself. For example, prompt engineering, right? So if you want to, if the better prompt you give the system, the better answer you're going to get, and the more optimized solution it's going to give. So how do you kind of control what the user puts into the prompt? You can't, right? So what you do is you put a layer before the prompt even reaches your system, and you make sure that the prompt is, you do some prompt engineering on your end, which will make the prompt better. So people who write, please can you give me an answer to so and so? Can you kindly give me the result of this thing? Well, you're burning tokens by using those words. So it might not be the best way to prompt your system. So removing all those words, just doing simple things like removing those words, making your prompt shorter, making it more defined to your system really helps with this. You could choose to produce shorter outputs, right? That's another way of optimizing your system. Maybe you don't need that full explanation for your use case. You could just have a very short explanation. So most of these are more about system design than the actual, AI model itself. But yeah, so that's another thing to keep into mind is LLM in production. End-to-end evaluation, user engagement metrics. So what is the rate that your users are engaging with your model at? You got to track that. There are a lot of dashboards out there that do this today, but you probably want to track how much interaction is happening. You can take feedback from your customers. What we do is our chatbot basically has like a thumbs up and a thumbs down token. So every time the user interacts with the chatbot, they can either say, oh, this was great, or it wasn't great. So that way we get a kind of a feedback from the user. Then there is session metrics, which can be used. So how much time does the user spend? Now, traditionally, we've seen that conversion rate, when we talk about conversion rate with websites and stuff, the more the customer engages, you feel like the better it is, right? But that's not true with LLM. Maybe they're just engaging a hell lot because they're not being able to find the answer that they want. So that's the end of my presentation. That's my LinkedIn profile. If you guys want to connect with me and kind of, talk more about LLMs and evaluation, I'm happy to do that. Thank you so much, and I'm going to open it up for questions if anybody has any questions about evaluation or anything anybody wants to share. Wow, no questions? Okay, that is very surprising. Okay, let me ask you guys a question. Are you guys doing LLM evaluation within your companies right now? Anybody who's doing LLM evaluation at all? Okay. Y'all are using oh, and Phoenix. Okay. Perfect. So, oh, great. Thank you so much. Perfect. Thank you so much, everybody. It's been great.